Good afternoon, students.
Good afternoon, ma'am.
So, what happened? So, yesterday's holiday was not sufficient, or what? There is very less attendance today. काय झालंय?
जॉईन होतील मॅम.
ते ऑनलाईन लेक्चरचा कंटाळा यायला लागलाय, असं काही आहे का? I think almost everyone's syllabus must be near to the complete. Yes or no?
येस मॅम.
सगळ्यांचा सिलेबस कम्प्लीट होत आले असतील बऱ्यापैकी.
हा मॅम, एक किंवा दीड
So,
चॅप्टर राहिलाय हार्डली.
okay. So how is your study going on?
गुड
असाइनमेंट्स
मॅम.
वगैरे कंप्लीट करताय बाकी सब्जेक्टचे? ओके, सगळे कंप्लीट करताय? ओके. मी गेट फॉर्म साठी तिघींना सांगितलं होतं. आय थिंक रोल नंबर 8, 18 and 32. Am I correct? Are the present? तो फॉर्म भरलाय का त्यांनी? पण गुगल फॉर्म अपडेट केलाय का? रोल नंबर 8. I think she is not there. 18, Pallavi.
येस मॅम.
ओके, फॉर्म भरला ना?
हा मॅम, भरणार आहे.
भरणार आहे? अरे 30 तारखेपर्यंतच भरायचा होता गेटचा फॉर्म, तुम्हाला मी सांगितलं होतं ना?
हा मॅम, पण 7 तारखेपर्यंत डेट वाढली म्हणून सांगितलं.
अरे पण त्याच्यानंतर ती जी तुम्हाला स्कीम होती ना, जी प्रेरणाची,
हा हा.
तर त्याच्यामध्ये तोपर्यंत नाही होत, म्हणजे 30 तारीखच होती ना लास्ट डेट त्याला. बघा आजही होत आहे का? आणि ते गुगल फॉर्म अपडेट करा. मग आठवले मॅडमशी एकदा बोला. प्राजक्ता,
हा मॅम.
व्हॉट अबाउट यू?
कोणती प्राजक्ता मॅम?
32, रोल नंबर 32.
येस मॅम.
Okay, have you completed all the details?
हो मॅम.
हा, फॉर्म भरला, गुगल फॉर्म भरला, तो जो शेअर केला मॅडमने
हो, भरला.
त्याच्यामध्ये स्कीम. Okay. We are discussing about VHDL again. Introduction to VHDL. In that, we were discussing about basics of VHDL, and till now we have discussed about what are the different data types, then how to declare library entities and architecture declaration. That part that we have discussed. So, in continuation with that, we are now going to proceed further. Okay, so I'll share my PPTs now. So today we are going to discuss about sequential statements. Okay. So whatever are the sequential statements in a VHDL that we are going to discuss. Now what is meant by sequential statements? Okay. Most of the time I am saying that okay, we are going to use sequential statements, so that is why we are going to use process, and then so what is meant by sequential statement? the statements that we are going to execute sequentially or step by step, that are the sequential statements. Okay, so here you can see in the slide also the first statement, that is sequential statements that specify the step by step behavior of the process. They are executed starting from the first statement, then second, then third, until the last statement. Okay, so that means sequential statements are those statements that are executed one by one. Okay, so पहिलं जे स्टेटमेंट आहे ते आधी एक्झिक्यूट होईल, त्याचा रिझल्ट येईल, मग त्याच्यानंतर दुसरं स्टेटमेंट, त्याच्यानंतर तिसरं स्टेटमेंट, आणि मग असं कंटिन्युएशन होत जाईल. आणि दीज आर द स्टेटमेंट्स दॅट आर कॉल्ड एज अ sequential statement. The statements within a process are sequential statements, whereas the process itself is a concurrent statement. Okay, so remember that the statements which are in the process. Okay, so when we declare a process, so whatever are the statements that are present in the that process, that are the sequential statements. That means that will get executed one by one. Okay, but if there are number of processes that are present, then they will be executed concurrently. That means they will be processed simultaneously. Okay, प्रोसेस मधले जे काही स्टेटमेंट्स असतील ती काय होणार आहेत, सिक्वेन्शियली म्हणजे वन बाय वन एक्झिक्यूट होणार आहेत. पण ज्या काही प्रोसेस असतील, म्हणजे आता समजा तुम्ही बघितलं असेल की आपण जेव्हा टेस्ट बेंच लिहितो तर त्याच्यामध्ये दोन प्रोसेस असतात, की एक क्लॉकची प्रोसेस असते आणि त्याच्यानंतर एक स्टिम्युलसची प्रोसेस असते. या दोन प्रोसेस आहेत, तर या दोन प्रोसेस काय होणार आहेत, कंकरंटली म्हणजे पॅरलली त्या एक्झिक्यूट होतील. म्हणजे आपल्याला एक क्लॉक तर मिळतं की आपण दोन्हीचे हाफ हाफ डिव्हिजन करतोय, म्हणजे जो काही टोटल टाइम पिरियड आहे त्याचा हाफ डिव्हिजन करतो आणि ऑन टाइम आणि ऑफ टाइम जो 50% ठेवतो, हा एक प्रोसेसिंगचा पार्ट झाला. आणि दुसरं काय आहे की आपण स्टिम्युलस देतोय, म्हणजे आपण इनपुट देतोय, जे काही आपले इनपुट आहेत त्यांना त्याचे व्हॅल्यूज असाइन करतोय आणि त्याच्यानंतर एक्झिक्युशन करतोय. सो दीज टू स्टेटमेंट्स दॅट विल गेट एक्झिक्युटेड सायमल्टेनियसली, but or sorry, these two processes that will get executed simultaneously, but whatever are the statements that are present in particular process, that will get executed sequentially. Okay, so here there are different sequential statements. Okay, so these are the sequential statements that are present or that are defined in a VHDL. That is the variable assignment statements, then signal assignment statements, then if statements, then case statements, null statements, assertion statements, loop statements, next exit statement, then wait statement, procedure calls, and return statements. All these are the examples of sequential statements. Okay, so all these statements that will get executed one by one. Okay, so first statement that will be executed first, after that second that will be executed, then third, and then last. Okay, till that means if we consider if statement. Okay, so first of all, whatever is the instruction or statement in that if loop. Okay, so that will get executed first. If that is false, then it will go to the next. Okay, if that is also false, then it will go to the next. Okay, so in that way it will get executed. So these are the sequential statements. Okay, so one by one we will see all about these once again. Okay, so first of all, let us see variable assignment statement. Okay, now what is mean by variable assignment statement? It is the statement that replaces the current value of a variable with a new value specified by that expression. Okay, so that means suppose I am saying that a is assigned. Okay, so a is a variable which is assigned to a and b. Okay, so this is just an example. Okay, so that I am taking. So whatever is the result of execution, that is a and b, that will be assigned to a. Okay, so that is the variable assignment, but this happens at that moment. Okay, so that means it will, that result will be there. Okay, within or that result will be uh, given or assigned immediately. Okay, so the syntax for this variable assignment is a whatever is the target variable. Okay, so variable, so it is a variable name colon equal to. Okay, so this is the operator that is used for variable assignment. and then expression and semicolon. Okay, so this semicolon that represents end of this statement. Okay, so when a variable is assigned, the assignment executes in a zero simulation type. In other words, it changes the value of the variable immediately at the current simulation type. Variables can only be declared in a process or subprogram. Okay, so these variables that we can declare in a process or in a subprogram only. Variables declared within a process cannot pass values outside of the process. That is, they are local to the process or subprogram. Okay. So the meaning of this is we can declare these variable statements, assignment statements in a process only. Okay. And we cannot use that variables outside of that process. Okay, so they are just local to that process. That means suppose I have written a process, certain process, and then I use a particular variable. Okay, so I cannot use that variable in another process. If I have to use like that variable in that another process, then I will to once again declare that variable in that process, but I cannot use the variable which I have used in one process that cannot be used in the another process. So that is a variable assignment statement. So this is the example. So here variable A and B, these are declared in this process, so that are used after. Okay, so here there is a expression that is used here for this variable declaration. Okay, so whatever is the result of S1 plus 1, okay, that will be assigned to this A variable immediately after this calculation. Okay, that means in that clock cycle only. Okay, uh, if we are having a sequential circuit. Okay. Then there are some another examples. Another example of this variable, that is a B, which is assigned to S2. Now what is meaning of this operator? Asterisk. What is meaning of that operator?
Bit by bit multiplication.
Okay. Any another answer? So it is a multiplying operator. So S2 multiplied by 2 minus 3. Okay, so here now you can see here whenever we have declared this variable, we have used int 16. That means it will be integer value. Okay, so we can use these operators only when we are using integer values. For boolean we cannot use this. Okay, so that means uh, for bit values we cannot use these operators. Okay, so this is about the variable assignment statements. Now next is the signal assignment statement. A signal assignment statement, it replaces the current value of a signal with a new value specified by the expression. Okay, so here if we are having a certain signal, so whatever is the expression that we have assigned to that signal, okay, so that value will be assigned to that signal. Okay, the signal and the result of the expression that must be of the same time, and that is the condition when we are using or when we are declaring these statements in a VHDL, because as we know that VHDL is a strongly typed language. That means we need to consider this type of data type very correctly. Okay, so here the syntax is for this signal assignment, that is a target signal which is assigned to whatever is the transport. Okay, so if we are using a delays, then there will be a transport, otherwise it will be expression and then after time expression. So whatever is this in a square bracket, that is optional, so you just can assign signal like a target signal assignment operator, that is a less than or equal to and then expression, and after that there is a semicolon. So this is the syntax. Okay, just a simple syntax that we use uh, most of the time. But here there is a, in a square bracket, it is a word, that is a keyword transport. It is there. It is to introduce delay in the circuit. Okay. So and then whatever after that, if we are using this keyword, then there will be a time expression. So after how much time expression, this expression will get executed, that is assigned here. So when a signal is assigned, assignment will not take effect immediately. Instead it will be scheduled to a future simulation time. There are two types of delay that can be applied when scheduling signal assignment. So, whenever we are executing any this signal assignment statement, that time this signal is not assigned, or this action will not take effect immediately, but it will take certain time depending on how much time we have scheduled. Okay, so there are two types of delays, that is a transport delay and inertial delay. Okay. So let us see now what is delay. Okay. In VHDL, the designer has the possibility to perform a signal assignment after certain amount of time, implementing the delay in the assignment. So that means this is the facility that is given to the designer to add certain delays in the signal assignment. Okay. So that that action will get performed after certain time. Okay, so that means suppose we don't want output exactly at the same time whenever we are changing the input, but we are assuming that there will be certain delays or there will be certain actions that will take place inside the circuit, and then it will take certain time. Okay, so in a actual circuitry or the practical circuitry, so assuming that we are introducing these delays in a whenever we are writing a VHDL code. So VHDL delay type, they are of two types. One is the transport delay and another one that is the inertial delay. The transport delay, that is used to model the delay which is introduced by wire connections or PCB connections. As you know that whenever we are using different components, okay, they need to be connected with each other, and therefore we need to use wires to connect that components. Okay, or at the same time whenever we are mounting that component on particular PCB, so there we need to do connections. Okay, so because of that, as you know that there will be certain capacitances that will be produced and which will produce a delay in the circuitry, and that delay is called as a transport delay. Okay, And another delay, that is the inertial delay, which is the delay which is introduced by the analog port, which means it is analogous. It is analogous to the delays in the device, okay, that respond only if the signal value persists on their inputs for a given amount of time. Okay, that means inertial delays, that is because of the components which we are using. Okay, so or we are using transistors whenever we are going for the VLSI. So it may take certain time. Okay, so how we are connecting all these transistors with each other, depending on that, it may take certain time to respond for the particular input. Okay, that means whatever stimulus that we are applying to respond, that it will take certain time, and because of that there will be certain inertial delay, and considering that delay, we can introduce particular delay in the code itself, so that we can imagine, or we can get idea about what will be our output if we have this much inertial delay or this much transport delay. Okay, so it is useful in order to ignore input glitches whose duration is less than the port delay. So these inertial delays, these are important, so that we can, if suppose there is any glitch is present, or suppose there is a certain spikes that is present in the input, and that is just a moment reaction. So because of that, output should not change, but it should change only when input is remaining constant. Okay, so to get that particular output, we are introducing inertial delay in the circuit. Okay, so that is the model that we are introducing. So inertial delay, that is the default delay model, and it is suitable for modeling delays through devices with inertia. That means for logic gates, then pulses shorter than a device's delay are not propagated to its output. Then transport delay, that is the model delays through elements with no inertia, for example wires, and low inertia, that means all input events are propagated to output signals and any pulses, no matter how short it's propagated. And then there is a one more type of delay, that is a delta delay. Now, if it is a very small value delay, okay, and it is automatically inserted by the simulator to preserve correct ordering of events. Okay, so this is inserted by the simulator, so that uh, we can get exact output. Okay, or whatever are the events that we are ordering in that particular code, so that should be executed properly. So for that purpose, we are introducing a very small value of delay in the circuitry. Okay, so delta delay is a special case of inertial delay with delay infinitesimally small. So now let us discuss about inertial delay. So the inertial delay model is the default delay implemented in a VHDL because its behavior is very similar to the delay of the device. The delay assignment syntax is out, okay, output 1, that is assigned to. Then there is a keyword inertial, okay, and then input. Whatever input, it may be just a variable input signal, or it may be any expression that could be there. And after time expression. Okay, so this is the time expression. So here, after how much time period it should be assigned, so that is mentioned. Okay, so here it is assigned as a 8 nanosecond, and out to, that is assigned to inertial input after 2 nanosecond. Okay, so this is the syntax for the delay assignment, inertial delay assignment, which is because of the analog parts which are present in the circuitry. Okay, so now here this uh, assignment Okay, here you can see that there are different statements. Okay, so there are three different statements for the same output too. Okay, which is um, specified as a output 2 is assigned as an input after 2 nanoseconds. Okay, so it will be same as that of the inertial input after 2 nanosecond, or we can also specify or declare it as a output 2 is assigned as a reject 2 nanosecond inertial input after 2 nanoseconds. So all these are the assignment statements which are equivalent. Okay, so now let us simulate this and just see how this delay gets introduced. Okay, so I'll take a very simple example to introduce this model, delay model, that is the inertial model. My screen is visible. Hello, my screen is visible.
No, ma'am.
Ma'am, it is a black color slide.
Now is it visible?
Yes, ma'am.
So let us uh, start with a new project. I give the name to this as a delay model. Right? Okay. Now I will use just a simple gate. Okay. So AND gate, let us use. So I'll give port names as a and B, the two input AND gate, and then one output, that is a Y. And then so now here this is the VHDL code. So just we need to write an expression in architecture. So I'll assign Y. Okay, this is the signal assignment. So A and B. Okay, this is just a simple VHDL code for AND gate. Okay, I'll just save this. No need to check syntax, but still I'm checking. With RTL schematic, you can see here AND gate is there. So this is a AND gate. Okay, so let us close this and I'll just initially, now here we have not introduced any delay. It is just a very simple AND gate code. Okay, where whatever is this expression that is executed first, and then the result of this will be assigned to Y. Okay, that means to the output. Okay, so I'll just initially simulate this, and then after that we are going to introduce delay. So now I think I have given the name. Okay. Associate this with the de inertial, that is the code that we have written. then finish. Okay, so here you will get a test bench code. Now I don't want this clock, so I'll just comment it. Then I don't want this clock process, so I'll delete this completely. And then I'll write a, here also I don't want this, so I'll delete this segment also. So I'll use 10 nanosecond because I will use a very small time period. Okay, then I'll assign value A equal to 0, B equal to 1, because initially 0 values that are initialized. So I am taking this value. I'll copy this code and paste it once again. Now I'm going to wait for 10 nanoseconds and then change this stimulus. Okay. So first value that we have given as a 0 1, then 1 0 1 1. Okay, so these are the values for A, and initially we have assigned here initial value for A and B, that is a 0 0. So that means all the input combination that we have considered. Now what should be our output? Whenever A and B both are 1, then only output should go high, otherwise it should remain low. Okay, so let us save this, go for the simulation, select test bench code, then expand this isim simulator and check for the syntax. Okay, so it is correct. Now let us simulate. Now what you observe here? Okay, just see, whenever input is 0 0, output is 0 0 1, output is 0 1 0, output is 0, and 1 1, it is 1. Okay, now the instance at which both the inputs are becoming 1, output is going high. Okay, so this is our simulation whenever we have not introduced any delay in that code. ओके, लक्षात आलंय सगळ्यांना? इथे इथे काय झालंय आपलं, की जेव्हा तुमचं इनपुट बी हाय जातं, म्हणजे ए तर ऑलरेडी हायच आहे, पण ज्या वेळेस तुमचं बी हाय जात आहे त्याच इन्स्टन्सला ए वाय पण हाय जात आहे. ओके, सो द इन्स्टन्स ऍट विच यू आर input is changing, output is changing. Okay, so that is the assignment that we have done. Okay, so that means there is no any delay introduction in this statement. Okay, so now इथेपर्यंत लक्षात आलं तुमच्या सगळ्यांच्या? Okay, so now I will close this simulation part. Okay, and then once again I will go to this VHDL. Okay, and now what I will do, I'll just, okay, माझं आधीचं स्टेटमेंट काय होतं, y assigned to a and b. Okay, now I'll just make this as a y assigned to inertial and I'll just make a bracket here. Okay, after 2 nanoseconds. Okay, so what I did, I just change this y assigned to A and B to the statement that is a y assigned to inertial A and B. That means now here we have used this input actually, that is A and B after 2 nanoseconds. Okay. Now remember that whenever you are having any timing expression, there should be space between these. Okay. Unit and whatever is the value. So there should be space. So here 2 nanosecond, because this timing unit, that is the keyword, and otherwise you can see here there will be error. Suppose I just save this in the same way. Okay, but you can see here. Oh, but that's not correct actually. This should be space. Okay, RTL schematic, that is not going to change, so it will remain as it is. So this is the RTL schematic, that is the AND gate. Now, so these are the changes that I have done in the main code, that is the code for de-inertial, where we are going to introduce the delay. Now I'll just go to the test bench to simulate this, and so for this we'll just go for the simulation. Now as I have changed VHDL code of this de-inertial, so here you can see a question mark. So just once again check syntax of this test bench. So it is completed successfully. So now let us simulate. Okay, there is certain error that was. Okay. Now see this. So whenever input is 0 0, output is 0. Then when it is a 0 1, 0 1 0 0. Okay, but 1 1. Okay, here it has been, B has been changed to 1, but it is 0 at initial and it becomes 1 after 2 nanosecond. Here you can see at 32 nanosecond it has been changed to 1. Okay, output has changed to 1 from 0 logic level. Okay, so that means as we have introduced 2 nanosecond 0 delay, so output is changing after 2 nanoseconds. So similarly, you can add a delay depending on the whatever are the delay that is going to be introduced because of analog parts. Okay, so this model that you can generate. ओके, सो म्हणजे बऱ्याचदा असं होतं की तुमच्या कंपोनंट्स मुळे तुमचं डिले इंट्रोड्यूसच होणार आहे, तर तुम्ही तुमच्या आउटपुट मध्ये पण म्हणजे VHDL कोड मध्ये सुद्धा तो इंट्रोड्यूस करून ठेवू शकता की जेणेकरून ऍक्च्युअल डिले आणि मग तुमचं आउटपुट जे चेंज होणार आहे म्हणजे जे सिम्युलेशन मधून हे दोन्ही मॅच होतील अँड देअरफॉर यू विल गेट करेक्ट रिझल्ट. सो दिस इज द इनर्शियल डिले दॅट वी हॅव इंट्रोड्यूस्ड in the output. Okay, so is this clear to you all? So this is one of the delay model. Yes, is this clear?
Yes, ma'am.
Okay, so what we used a syntax that is a output assigned to inertial then expression or the input and timing expression, that is after what how much time period it is going to be or how much delay it will have in that execution. So this is the one type of the delay. Okay. So another type of delay, that is a transport delay. Okay. So the transport delay, that is because of the wires or the PCB connection. That means it is the delay which is introduced because of the signal transportation. So that is the another type of delay. So transport delay, syntax for that is again a transport, then input and then after timing expression. Okay, so the same syntax is there, but it is just because of the transportation. Okay. Now here you can see that this transportation delay that can be that will that may be present after though input is not available. Okay, but inertial delay will not available in that way. Okay, म्हणजे जर तुम्ही इंट्रोड्यूस केला समजा तुमचा सिग्नलचा टाइम पिरियड हा 10 नॅनो सेकंड आहे बट तुम्ही 20 नॅनो सेकंडचा डिले इंट्रोड्यूस केला तर त्यावेळेस तुमचं इनपुट सिग्नल हा हाय नसणार आहे तर इनर्शियल डिलेला तुम्हाला आउटपुट मिळणार. ओके, पण तेच जर तुम्ही ट्रान्सपोर्ट डिले असेल तर तिथे तुम्हाला किती वेळाचा तुम्ही डिले इंट्रोड्यूस करू शकता आणि मग तुमचं आउटपुट ज्याप्रमाणे तुमचं एक्सप्रेशन आहे त्याप्रमाणे तुम्हाला आउटपुट मिळेल. ओके, सो लेट अस चेक दिस अगेन इन द VHDL कोड. ओके, आता मला माहिती आहे की माझं म्हणजे मी याच कोड मध्ये आधी चेंजेस करते की माझा टाइम पिरियड काय आहे 5 नॅनो सेकंड आहे ऑन टाइम. ओके, म्हणजे इथे मी जर बघितलं इकडे ओके हा टाइम पिरियड किती आहे मी हा कंटिन्युअस ऑन ठेवला तर तो मी आधी चेंज करते. क्लोज दिस and then I will make this wait for 10 nanosecond. Okay, so that means A and B will be high for 10 nanoseconds only, and then after that it is going to be 0 0. Okay, so I'll make this A and B that is equal to 0 0. So now once again save this and let us simulate this. So here you can see that A and B are high for 10 nanoseconds only. Okay, so output will become high after 2 nanoseconds and then it will remain high for the 10 nanoseconds only. Okay, so at 42 nanoseconds it will go low though input is high, sorry low at 40 nanoseconds. So here it is going to be low. म्हणजे ऍक्च्युअल टाइम पिरियड हा 10 नॅनो सेकंडचाच असणार आहे जेवढ्या टाइम पिरियड साठी तुमचं इनपुट आहे पण ते उशिरा सुरू होईल म्हणजे इथनं तुम्हाला आउटपुट मिळेल. ओके, म्हणजे आता ऍक्च्युअल काय आहे की आपला 10 नॅनो सेकंड साठीचा तुमचं दोन्ही इनपुट्स हे हाय आहेत तेवढ्या टाइम पिरियड साठी. ओके, सो नाऊ आय विल चेंज in the code like this. Here I will make this as a 12 nanosecond. Okay, so what I am doing, I am introducing inertial delay of 12 nanosecond and let us see what is the effect on the output. Okay, so I'll just go here and I have saved this, so I'll just simulate this now. So here your input is high, okay, both the inputs are high at this instant, but output is remaining zero. Now why this is happening? Because we have introduced a inertial delay of 12 nanoseconds, and at that instant no any input is high. Okay, म्हणजे जी काही तुमची ऍक्च्युअल कंडिशन असायला पाहिजे ती नाहीये, त्यामुळे तुमचं आउटपुट हे झिरो येते. Okay, so this is the case for the inertial. Now I think yes, we can complete this part. This part. Okay, and I'll just go for the transport. Okay, so here I'll just make a change, that is a transport. Okay, and then this initially I'll make it as a 2. Okay, save this, then go to the test bench. So here you will not find any difference in the earlier inertial. इथे जो तुमच्या लक्षात नाही येणार आहे, म्हणजे इथे फक्त तुमच्या लक्षात येत असेल इथे डिले इंट्रोड्यूस झालाय. ओके, आणि हा आपण आता 2 नॅनोसेकंड आहे, तर तो वायर्समुळे इंट्रोड्यूस झाला असं आपण कन्सिडर करतोय, म्हणजे ते मॉडेल करतोय. तो इथे तुमच्या लक्षात येईल की इकडे तुम्हाला आउटपुट हाय मिळते. ओके, आफ्टर though both the inputs are high at this instance, but after 2 nanosecond only output is going high. Okay, so this is the one part. Now I'll just make that time period as a 12. And now let us see the difference in the inertial delay and the transport delay. See here. Okay, now what you observe here? Okay. Here after 12 nanosecond you are getting the output that is high, which is going to remain for 10 nanoseconds. Now why this is happening? Because this is the delay that is introduced by the because of the wires. Okay, जे वायर्समुळे होते, त्यामुळे वायर जोपर्यंत तिचा जो काही टाइम पिरियड आहे त्याच्यामुळे जो इंट्रोड्यूस होणारा डिले आहे तो 12 नॅनोसेकंडचा आहे, तर त्याच्यानंतर आउटपुट हाय जाणारच आहे. पण इनर्शियल डिले मध्ये काय आहे की तो अॅनालॉग कंपोनंटमुळे इंट्रोड्यूस होणारा डिले आहे. तर जोपर्यंत तुमचं इनपुट तिथे हाय असणार आहे तरच आउटपुट मिळणार आहे. ओके, म्हणजे जी कंडिशन लागणार आहे, एक रिक्वायर्ड आहे तुमचं आउटपुट हाय येण्यासाठीची, ती जर त्या 12 नॅनोसेकंड इतक्या टाइम पिरियड नंतर, म्हणजे जो तुमचा डिले आहे तेवढ्याच्या नंतर सुद्धा जर ती कंडिशन अवेलेबल नसेल तर आउटपुट हे हाय जाणार नाही, म्हणजे आउटपुट तुम्हाला प्रॉपर मिळणार नाही. ओके, सो दिस इज द डिफरन्स बिटवीन द inertial delay and the transport delay. Okay, so let us discuss about next part in the next session. Okay, so for today we have discussed about the delays. Okay, we are going to discuss about delta delays in the next session. So for today we will stop here. Okay, you may leave this meeting now.